Guys, please quiet. And now, guys, we are gonna solve it together. Please, everyone, look at the board and make sure that you take notes because I'm gonna give you a new lesson.
Okay.
And now I'm just gonna give you the queen of the triangle, the queen law of the triangle. Yes. It's not on the Zoom. Oh, thank you. Let me share the screen. Thanks for reminding me of that. Now, guys, Sabrina, Lex, Lucas, quiet. Now, look at this. The thing that we just want to do, we see that this problem that we have, Janaya. We have the angle, which is 110, and we have two sides of a triangle. I'm just gonna go to, let's say, the Zoom, because because the first thing that guys you learned was that when we have a practical example that it needs trigonometry, we do not bother ourselves with the details. For example, the shape of a boat, it doesn't matter. Now I'm gonna convert everything from this diagram into the Zoom by representing it just by a triangle. I'm gonna stop the share here now and just share it on the Zoom. Now, look at this. We had a triangle. One of them was, the side was this. The other one side was this. The other one was this. We said that also. We said this point is Q. This point is Q. This point is R. The angle here is how much? 110. Thank you. And also, how much is this length? Fantastic. And how much is this length? Yes, almost. Yes, that's correct. Guys, unmute yourself if you're on the Zoom. Unmute. Mute yourself. Yes. Okay, everyone is muted now. Thank you. Now, we're going to use the same thing. Guys, look at this. That example now is just represented by that triangle, the same scenario that we have. Now, what is the task? We notice that now we have these sides, P and Q, and we have Q and R, and we have the angle between them. And now what are we looking for is that we are looking for this side. But if you remember, I'm just gonna very briefly show you, Sima, the thing that we did with the king law of the triangles, then see if it can be related to here. For example, A, B, C. This length is B, this length is C, this length is A. The thing that we saw as the king of the triangle before the break was this. We said that, for example, the sine of the angle A, which was essentially here, over A, equals what? Equals another ratio, for example, the sine of this angle. See? This angle is looking at which side? See, that's right. Thank you. Equals the last ratio, sine of which angle? B. The angle B, which is here, which is the side that she's looking at. Fantastic. That was the king law of the triangle. What was it good for? We saw that when we have, for example, an angle, and for example, one side, or two angles one side, or one angle, two sides, we can find the other one. Then everything about the triangle is given. But look at this one, the scenario that we have. Let's see if the king law of the triangle is going to be relevant there, and if it's going to help us. Lucas says no. Why?
So if we were to develop our ratios, we know that PR is X, because you don't know it. So we do know that the angle of it is 110.
That's right.
That's one variable that we don't know. So we can't solve it with two variables yet.
Exactly.
So we need another angle.
Fantastic, brilliant, thank you. What happened? Because look at this. We are looking for this side. And we do not have any angle. Maybe you can say that, okay, I have two sides. I have, for example, I look at these two. But the problem is that, guys, look at this. And there is a huge problem. Everyone, please look at this. It is very important because if you do not understand the difference, then we cannot proceed further. Everyone, look at this. Look at this law that we have over there. We say that what? We said that if we look at point P, and as Lucas said, and R, we said that if we just want to use this law, we said that the sine of P, let me write it. We said that sine angle P, the angle P is looking at which side? 4. That's right, 4, thank you. Equals to what? Sine of R. R is looking at which angle, which side? Fantastic. And now look at this one. We have one ratio, one equation, but do we know what is P, what is R? No, and you're stuck. We got stuck there and we cannot find anything. Because if I use this law, which we call that the King law, we cannot find it. We cannot find anything because we have one angle, one equation, but unfortunately, two parameters is not now, which is P and R. And that's a problem. Now, it means that I cannot use this law. Yes.
So we can say basically the rule of thumb, like it's like if you have three variables and one unknown, then you can follow it.
Exactly. Either two angle one side or two sides one angle. Here is impossible. Then as Lucas said, you have to think of a different solution. And what is going to be the different solution? I'm so impressed by your work. No, it feels good. Now everyone is writing, huh?
Yeah.
Good, are you writing, huh? I'm Robert, are you writing my piece of paper? Oh, that's paper. That's impressive. I'm so glad everyone is taking notes. Fantastic job, guys. Give it for yourself. Okay, now, guys, go back to this. Everyone look at this. Now, what is the solution that we are just going to find here? I'm just going to use this one as a very general explanation. Then I go back to the case that we had. Then we talk it over there. What we say? We said that A, we said that B, we said that C. Similar case. And I say that for angle C is facing this side, and I'm giving the value of the C, and A is looking at that side, I give BC the value of, A. Means BC is going to be, for example, A centimeters, and BA is going to be, for example, C centimeters, for example. And we know the angle here, which is like the case that we had. We said that the angle is that, for example, is going to be alpha. General, it can be anything. Now, the case for us here is that we are looking for this side, which I called it what? B. Now, the case is exactly the one like which we had here. You will be taking your boats to go from P to Q, then from Q to R. You were looking for this. We say that we can write B as this. We said that the B squared, we had something like the Pythagorean theorem. Look at this. Let me also show the Pythagorean theorem. Because if we compare that, we can just see how similar they are. It is going to be hypotenuse. We had, let's say, for example, A. We had B, we had C. We had A, we had C, we have B. And we know that that's normal. What was the hypotenuse? What was the Pythagorean theorem here? Exactly. No, b squared, huh?
Oh yeah, b squared equals z squared minus.
That's right. It was a Pythagorean theorem that we have learned. But guys, look at this, what I'm gonna do.
Okay, yeah, never mind.
What happened?
Oh, sorry, I just thought, never mind. No, it's because you put the hypotenuse.
This is B is a hypotenuse, the one which is faced by the normal triangle. Now look at this one, guys. Everyone is okay with the Pythagorean theorem.
Yeah.
And now look at this. For the B, I'm gonna do the same thing. I write B is not normal. I write it like that. I say B squared equals A squared, like exactly what I did here, huh? Plus C squared. Huh?
Wait, is this for the angles?
No, this is B for the side. Like the Pythagorean theorem. Now, guys, so far, all the thing that we have done is nothing different than the normal triangle that we used specifically the Pythagorean theorem. Now, compare this one with this, the same thing. There is one tiny difference, and that's the difference. It's gonna be now, the term which is gonna be completely new is this minus 2 times length of A times C times cosine of alpha. This is we call it the tail of the Pythagorean theorem.
Why don't we need the tail?
Because look at that, we can prove it, but it's very advanced. We do not do this at this level. But remember, yes, but at this stage, we look at this law as the mother, as the queen law for every triangle. The case of the Pythagorean theorem was an exception. It's a simplified version because you can write it like that.
If you have an angle, if you have, like, for example, two sides that are unknown, we could use that. But if you have two sides and an angle, we can use the other one.
Exactly. No, look at this one. Look at this. And I'm going to explain. Look at the Pythagorean theorem. Because I said that the one which we have here is like the queen, and this is everywhere. I'm going to drive B using the Pythagorean theorem by that formula. If that's the case, then I have minus 2AC, which is A is here, C is here. I follow the same thing. Multiplies to what? Cosine of, what is the alpha here?
110.
No, alpha here.
90.
That's right. It's 90. Cosine of 90.
1.
Cosine of 90 is how much?
91.
0.
What, you said it was one?
No, sine of 90 is 1.
Oh.
Look at this. The right, I should say the normal, the unit circle. It's going to be here. For example, this is sine. This is cosine. 90 is this. You are standing here. How much is the value of the cosine? 0. Yes. That's right. If this is 90 degrees, look at that, Jana here. If that's 90 degrees, cosine 90 is 0, then 0 times minus 2AC becomes how much? 0. Then you see that the whole term is gone. Oh, we got to the Pythagorean theorem. Yes. And guys, look at that. From here, by using the queen formula, we got back again to the Pythagorean theorem because cosine 90 is 0, and these term all vanishes, and you're left with A squared plus C squared. Make sense?
Yeah.
Yes, everybody?
Yeah.
Colors, great. Where it goes? Oh, that's another orange one.
Yeah.
I like the orange color.
Yeah.
Is that your favorite
Yes.
color?
Of course. Now, so what you say about?
Is that your favorite color?
Yes,
Really?
orange, I like it. Now, guys, let's do something. Then we take a quick break. Then we come back to do some exercises.
Okay.
Now I come back to the original problem back. Original problem, what they were asking me. Everyone look at the board. We are going to solve the problem of the sailor on the sea. The boat moves from B to Q. Then from Q to R, we have T's two lengths. The angle is here. Using the Queen law, I'm just going to find the value of what, Sabrina? Of PR. What is going to be PR? If I called it Q, because this is spaced like that, PR, if this is Q, Matthew, I'm going to write Q squared is equals to 6 squared plus 4 squared minus 2 times 6, which is A as A, and times 4 cosine of 110. How much is cosine of 110? How much minus? 3,4. Then as a result, becomes 36 plus 16 plus 48, because minus minus becomes how much? Plus, we have 48. 6 times 4, 24. Times 2 becomes 48. Times cosine of 110, which is 0.
Why is it plus? Minus. Yeah,
Because the cosine is minus.
but you're not gonna multiply. You're not gonna be minus plus 48. It's gonna be minus.
Tell me first, how much is cosine of 110?
Minus 0.34.
That's right. Let me rewrite it again. You see what? Yes, look at that. Let me redo that. Maybe I jumped into the last conclusion. Minus 2 times, how much 2 times 6?
9. Wait,
12.
12.
12 times 4, 48.
2 times 4.
Let me write this. 2 times 6 times 4 times minus 0.34. Now look at this. I have 36 plus 16. How much? 52. And guys, look at this. How much is 2 times 6? 12. 12 times 4? 48. Minus 48 times minus 0.34. And now look at this. I have minus 48 times minus 0.34. Minus minus becomes how much? Plus. Then I have 54 plus. Can anybody put that in calculator? 48 times 0.42, 0.34. 16.32. Then the total becomes how much? 68.32. Now, guys, look at this. This is Q2 square. We are looking for the Q. In this example here, when we talked about the Queen law, obviously, the value of the B is square root of that value, a squared plus c squared minus 2ac cosine of phi. Isn't that correct?
Yeah.
Then as a result, like the Pythagorean theorem, if b squared is 68.32, b equals to what? Square root of 68.32 becomes how much? 8.34? 24.
That means that the distance is short go through Q because 6 was 4 times means I'm right.
That's right. Exactly. Imagine that. Lucas says that.
No, I was not about this.
For example, Lucas says that if I move from 6 to 4, from these two lengths, it takes me 10 kilometers, and I have to spend more gas. But if I spend from Q to R directly, I have short distance. It's 8.2 kilometers. Then instead of going all the way like that, then I calculate that I have the distance PR is just 8.2 pounds. And it's much better. Then you saw that I used the Queen law of the trigonometry, which is the called cosine law. If you see anywhere in the textbook that they talk about the cosine law, this is this one, because look at this, the cosine here. But I called it the queen, but that's cosine.
The first one was, what's the actual name? for it?
Sine law. Because you have the sine ratio. Look at this. Because you had the sine ratio, they called it sine law. This one, they call it cosine law.
Is there a tangent one?
No.
Is
Just
there a, what's the other one again?
sine law.
But there's another one.
Secant.
Secant, cosecant, cotangent. Any questions, guys?
Cosine of the secant.
Any questions? No?
5-minute break.
Great.
Yes.
20-minute break.
Guys, if you have no questions, hold on a second. Hold on a second. If you have no questions, please take